Yeah, today's session is just introduction to the Azure Data Engineering and giving some demo on this topic like Azure Data Engineering. Okay, just let me start then. So we can break this session into like three parts, like first introduction, and then describing how the what components will be present in Azure Data Engineering, and we can go through with some of the components, and then we can start theoretical explanation of that components, and then we can give small demo of practical usage of that component. Yeah. Okay. So if anyone have doubt, just you can ask me. Okay. Meanwhile, so coming to introduction, so myself, Vishnuvardhan Reddy. So I'm a full-time data engineer from past 7+ years. Previously, I'm a SQL admin. So from there, I started working on some ETL background, and then I got into introduced to Azure environment. Then I moved to Azure. So basically, I am not a like a coding developer. So anyone can learn Azure data engineering, and so basically we do need to have some logical understanding and some basic understanding of SQL. So then any person which have those skills, we can able to become Azure Data Engineering. And I'm a certified Azure Data Engineer. So from past 3 years, I'm certified Azure Data Engineering engineer, where I have worked in multiple companies, in multiple projects. I have worked as Azure Data Engineer. So yeah, so may I think this course is meant for Azure data engineers who want to become Azure data engineer. And also this course little bit covers around like 70 to 80% of DB 203 certification. But definitely we need to have go through a lot of other tools and some understanding about other data stack in Azure to complete this certification. So I have done that the certification 3 years back. Previously, there are like two exams in this certification, 201 and 202. They have combinedly made it as a single exam, and if we pursue the exam DP 203, then we can able to become certified Azure Data Engineer. So yeah, this is my background. Let's start the topic with some like fun facts. So why do data engineers are becoming more demand nowadays? Can anyone answer this simple question? Anyone, please? Yeah, good. Yeah. Any other? Okay.
So day by day, the
Yeah.
amount of the data which we are generating getting increasing rapidly.
Yes. Yes. Who is this? May I know who is this?
Kita,
Yeah, yeah. So basically, yes, what you told is absolutely correct. The amount of data we are generating each day is like 328 million terabytes of data we are generating each day. So what most of the data is in the form of videos like binary format and other format, but some of the data is business data and consumer data. So we will be extracting this much of amount of data in each day. Where do these data goes? Like these data will be gone to at least some business data will go to process in the form of it will process, and it will be created as a reports for analysis of that particular business. So basically, this huge amount of data is derived in each day, and how this data is transformed and how this data is becoming like generative reports nowadays because of our data engineers. So basically, data engineers are most crucial nowadays, and this domain is becoming very much demand nowadays. So yeah, I hope a lot of you may know the demand for the data engineer nowadays. So this is what like why data engineers are important nowadays. So as you see, according to these exploding topics, last year we have generated around like 120 zettabytes of data. So and there are some estimates in 2025 there is like 180 zettabytes of data is generated on each day. So that's why data engineers will become more and more demand in coming years. So I'm appreciating all of you that you have taken this at least this course, like at least this demo, like why data engineers are becoming demand. So yeah, definitely I appreciate you all to at least signing up for the demo for this course. Yeah. So mainly in Azure Data Engineering, we do have multiple components. So basically, there are like tools. This course, we need if you want to pursue Azure Data Engineer, we need to definitely have knowledge on these components like Data Factory, Databricks, Synapse Analytics, Azure Data Lake Storage, and Azure Stream Analytics, and other Azure data stack. Like there are a few newer technologies are coming into Azure data stack, which is called Microsoft Fabric, which is an end-to-end analytics platform. So that is also very wonderful tool. It is an end-to-end platform. We can do all the components which are doing here can be done in a single platform, that is Microsoft Fabric, which is recently developed by the, and it is given general availability for the users from last December. So all these technologies we will be going through if we start pursuing Azure Data Engineering. So do you have any doubts? So at least I'm not able to hear anyone. Okay. Yeah. Thank you. Thanks for confirming. Yeah, let's make this session as interactive, because like if you have any doubts, just keep asking me. So I'll try to able to answer as much as possible. So for this demo, at least we can try to go through with like Databricks. What is Azure Databricks, and from where this word is came, and who developed Azure Data, who developed Databricks. So all this information we can go through now. So basically in Databricks, so basically in total Databricks course, we do have different contents in Databricks as well. First at least we need to understand what is Azure Databricks, like what is the architecture, what is who developed Azure Databricks, and what components present in Azure Databricks. Then we can go with like how to configure Azure Databricks, and from where we can deploy Azure Databricks at least. So under setting the clusters and all the things, then at least we need to have good knowledge about it. The main component of Databricks is PySpark. So mostly all the Databricks working we will be doing with PySpark. PySpark is a language which is which is like developed by the Spark team on the basis of Python. Like so, it is like a kind of a Python, but it will be having different functions, and all the components of a Spark components will be included in the Python. Yeah, we will go into the Spark SQL and Delta tables. So if we go through all the components, these are the components. And recently they have released Unity Catalog, which is an end-to-end analytics platform in Databricks. So that is also we can able to cover in this Databricks course. For this demo, I'm going with like Databricks architecture. So how it is created and who created this. So Databricks is a cloud-based platform for analyzing the data and transforming a huge amount of the data using PySpark, using Apache Spark. Apache Spark is a lightning fast distributed engine, so which is developed by the Apache Spark team. It's an open source engine. Main core of the Databricks is Apache Spark. Like it is inbuilt engine. So the Databricks tool is developed around the Spark engine only. So main features of this Databricks is so Apache Spark is basically open source tool, but Databricks is it's not a open source tool. At least it is a production tool. So it provides the different features on basis on top of Apache Spark. So these features are this unified workspace. It provided different workspace with the different UIs. So for each users, it can provide different UI. For data engineers, it can provide data engineers supported UI, and for data scientists, it provide data scientist supported UI. And it supports scalability of the compute power. So for each tool, we need to have some compute power, like processing power. For this laptop, at least it has CPU, RAM, ROM. Like that, for Databricks, for Apache Spark to run, we need to have compute power. So these compute power can be scalable because this Databricks is already present in cloud, right? So like if you have some basic knowledge about cloud, so cloud infrastructure gives scalability. It gives like we can increase a number of CPUs or RAMs based upon which cloud you are in, and it provides integration between the components. Like if you have a source, if we need to connect to the different sources, we can able to connect. We can integrate the code into DevOps, and we can integrate different. We can able to connect to different tools. So as per security purpose also, because security is very important nowadays, because definitely companies needs to follow different types of security governance because of the data. Data is very crucial nowadays, so that it Databricks provide different levels of security in the Databricks. So main use cases of the Databricks is like for processing data, like so the data is coming. Data is generating around 300 millions of data is generating daily, terabytes of data. So to process this data, we can use Databricks, like processing the Databricks. And to save the data also, we can use Databricks. Nowadays, after introduction of Unity catalog, so it became a data warehouse. It can create tables. We can create tables in Databricks, and we can do lot of lot of things which we are doing earlier in our on-prem databases or data warehouses. We can do in Databricks now. So, and for data analysis, for data, most of the data science work will be like analyzing data and creating models on top of the data, refined data. So data engineers will be doing processing of data, refining the data, and storing the data. These work will be done by the data engineers. And data engineers can also analyze the data, what data is present. After analyzing the data, we can keep some rules and refine the data. And data scientists always can do exploratory data analysis on that particular data by using all the libraries provided in the Databricks. And in Databricks, machine learning algorithms also supported. We can import machine learning models in Databricks, and some real-time analytics also we can perform in the Databricks. So do you have any doubts up till now? Like
So, when we are talking about the data warehouse, it's act like a storage.
Yes, it have meta stores actually. So in Unity catalog, after implementing Unity catalog, so the Databricks will connect to the Azure Data Lake. So that
Okay,
data lake acts as a storage.
okay,
So then we can make use of Databricks as data warehouse. So we can create tables like these tables, or we can create both external tables and managed tables. So yeah,
okay,
it's becoming data warehouse nowadays. Yeah,
okay.
yeah. Anything else? So then I can go ahead. So this is a diagram where like total data bricks is like Azure data bricks. For data bricks, the Apache Spark is a core component. So Apache Spark is a core component for Databricks, and these Databricks hosted in Azure. So that's why we call this as Azure Databricks. Databricks can be hosted in multiple clouds. Either we can host in Google, or we can host this in AWS. But what specialty Azure is giving is Databricks is a first party tool for Azure. Means it provides multiple integration with the Databricks, and so hence it is called like first party connector. So what other functionalities is Azure providing compared to AWS and Google? We can able to check in further slide. So as of now, just remember Databricks is first party tool in Azure. So that's why it became very much popular on at least in Azure platform. This Databricks. So yeah, so what is the Spark? So I am telling Spark is a core of a Databricks. Spark engine is a core of Databricks. So what does Spark engine have? Spark engine is an open source lightning fast tool lightning fast distributed engine, which is developed by the Apache Spark team. But so it is developed on drawbacks of on Hadoop. So what the drawbacks Hadoop is facing. So on top of that, they have developed Spark engine. This Spark engine is totally in-memory engine. Like it that total engine will be working in RAMs only, not in ROMs. So basically, it is a in-memory distributed lightning fast engine. It is faster, like 100 times faster than Hadoop engine. The old Hadoop engine, it will be 100 times faster because it run computes and everything in memory only. So that's why Spark became popular. And right now, I think Spark is giving like 3.5 version. Now we are running Spark as nowadays. But what is the architecture of a Spark? So when coming to the architecture, so we do have how the user submits the code, how the Spark engine take the submitted code and it will process that. That architecture we will be able to find. So whenever that Spark architecture is form of a master and slave combination, it have one master and multiple slaves. Like we can call master as a driver node and some other slave nodes as a worker node. If you know master slave architecture, which is present in Hadoop, the same architecture will be present here as well. So if anyone don't understand that, so you can always ask me, what is the master slave architecture? Yeah. Then so everyone do understand this architecture, right? Yeah. Okay. So yeah, so whenever a user submits a particular code to the Spark, so Spark context will be created. So what is the Spark context? It is a Spark context is just a function. It is created to perform the activity. So whatever the code submitted to the uh, Spark, so the Spark context is created. After that, it will connect to the cluster manager. What is a cluster manager? Cluster manager is nothing but nodes, like I told you, right? So we do have, just give me a second, guys. So yeah, whenever a user submit a code to the driver node, a Spark context will be created. After that, driver node contact the cluster manager. Cluster manager is nothing but, so whatever the worker nodes which are present, right? So those configurations will be present in the cluster manager. So all the, it will check with all the worker nodes, which worker nodes are free. So like it will connect to the all the worker nodes, which worker nodes free, and then these worker nodes so these worker nodes, you can assume this worker node as a single virtual machine, and this worker node is a single virtual machine. So in each worker node, we do have RAM and ROM. RAM is splitted into, we do have CPUs also, and the CPUs can be splitted into multiple stages and other things. It's very depth knowledge, but I'm giving high level knowledge of this worker node. So worker nodes, we can assume it as a virtual machine, and it do have RAM and ROM and CPUs. So it will check any process is running in the worker node. So if worker node is free, then cluster manager, what it will do, it will pass the information to the driver node. Again, these worker nodes are free. You can run your code, whatever code is present, you can run in these worker nodes. You can tell like it's a any person who is a manager or another person. So he will ask his employees who are free as of now, and he can assign tasks to that employees. Like that, this worker node and driver node will communicate each other like this. Like it will communicate with the driver node directly communicate with the worker node. Now the whoever free as of now, after giving, after the information provided by cluster manager, so it will connect to that worker nodes and it will assign that, it will create subtasks of the particular task, and it will send these subtasks to multiple worker nodes. So like this, like then after worker node will run the code, whatever the present in that, and it will submit the result to the driver node, and driver node consolidates all the results coming from the worker nodes, and it will send back the result to the user who ran the query. So basically, this is a Spark running architecture. So whenever we submit a code to a particular Spark, so all these processes will be happened within very like within milliseconds. This process will be running, and we can get the result in span of seconds. So how much data, huge amount of data also we can able to retrieve on this basis of this master slave computation. So and we can increase so this cluster manager is responsible for increasing the cluster nodes. If any worker node fails, so then we will be losing some data, right? Like, so at that point of time, it cluster manage create another worker node for that purpose. Like so as per the scalability, so since it is in cloud environment, it is scalable. The Spark architecture is totally a scalable architecture. It will create new worker nodes based upon the configuration provided in the cluster manager. So all this information I can give if we go through the course, but as per time constraint, I'm giving just a high level information for this. So and so this Spark context contains one more component like DAGs actually. This is direct acyclic graph. So these DAGs will be created. It's a logical plan. First, it will be created. If you have some background about SQL servers or SQL administration, there is some concept called execution plan. Whenever a query is run or any other query we run, first SQL engine will perform execution plan for that. That kind of plan is created in a Spark architecture as well, like direct acyclic graph plan. So yeah, that will be created. And so a lot of components are present in this Spark architecture. Just I'm giving high level information on this. So this is so everyone understand this, right? Do you have any doubts on this? So coming to the Azure Databricks. So what like yeah, tell me. Yes, sorry.
I got a one quick question.
Yeah.
So do you is it this class is run always at this time or a weekend class also?
So yeah, that one it's not yet decided. Mostly it will be on weekdays. Uh, Mostly on like Fridays and Wednesday and Fridays, or Tuesday and Thursdays.
Oh, okay, okay, all
Not
right,
sure,
yeah.
not sure, not sure, not sure. We need to decide yet.
You don't have early in the morning 7 or and or 8 a.m. IST class, right? For this.
Yeah, that one yet we need to yet decide that. So it's about like we can fix the timings with your availability only. So I think
Okay. Yeah, I live in EST time, so this time and the time we mentioned right now is on weekend I can attend. The rest one is I will be at an office, so I cannot attend. That is one thing. The one question is it this class will be good enough to assume that see for the DP 2 or 3?
yeah, it almost all covers around 70 to 80% for DP 2 or 3. So we do have some other components we need to learn for ourselves, like Azure Cosmos DB. It's a huge
Mhm.
topic. Definitely we need to go through that on individual purpose. Like individually we need to learn that, because that one is not covered in this course.
Okay,
So
that's fine.
and yeah,
The main important as a data warehouse is all the other one is not that much. You can use it in the real practical since I'm working on that. The real practical, real in the real world, it is most of the time. It's a rare case using the other application, but they use loading data from different part, from different
yeah,
source to SQL data warehouse, which is uh, and the dedicated or
yeah,
server SQL pool, and in that mainly delta load all that kind of data warehouse, fact, dimension, all that kind of partition. Do we cover those? That is the very
Yes,
important.
we do cover the yeah, we do cover those scenarios. So we do have multiple components to load from different sources. So Azure Data Factory is one component, and Azure
Hmm.
Synapse Analytic Pipelines is also
Yeah.
another component.
Hmm.
Both
Yeah.
both of them can do what you are telling. So yeah, we can cover those things. Definitely, those topics are covered in this course.
All right. Yeah, because data in data engineering, 80% of the cleaning data and the loading data. The rest one is very rare case as it's coming
Yeah,
to if not certification. So that's my concern. All right. Thank you.
sure, sure. Definitely, we can go through those topics because those are crucial topics for data engineers.
Very
Definitely, we
crucial.
can go.
Very crucial.
Yes, yeah,
If you don't load able to load data in partitioning a different load, cleaning and bringing load into the only in data engineering the request is we have a data coming to or this is storage or this application use the API bring the data load into for a
yes,
data analyst load it to SQL Server or load it to this place. So that is just what I come across is a lot of data engineering we work with is doing that. That is like 80-90% data engineering do that job. So that is only that my concern. If you cover that, that's very great.
yes. We can able we do can cover those topics. Yeah.
Thank you.
Okay. Yeah. Anyone else? Okay. Yeah. Then uh, then let me resume the topic. So yeah, Databricks is a cloud-based platform as service provided in all the clouds. So what differentiate Databricks in Azure is so basically Databricks in Azure. So it is like a first party connected to the Azure, and we do have some information of the Databricks here. Databricks is founded by the Apache Spark creators, like whoever created Apache Spark, they have created production ready tool that is Databricks, and it is present in all the cloud platforms. As I said, to make to run Spark much easier in cloud platform, they have created this Databricks company, a production based tool, which is a platform as a service tool, which is present in all the cloud environments. So as of now, Databricks is running on 14.3 runtime. Runtime is nothing but Spark configuration. On top of Spark configuration, Databricks provides much more functionalities. So all that, like it will add some other libraries as well, like machine learning libraries and other libraries like if you know geo libraries as well. So all the libraries will be included in the on top of Spark. So then it will create a runtime, and it is this Databricks runtime is much faster than vanilla Spark. So the vanilla Spark will be present always, so that we can able to download in our machines, and we can run Spark in our particular machines, like we can create one server, we can download the Spark, we can run the Spark, and we can configure different types of we can configure a cluster, and we can run the Spark vanilla Spark, which it is always free. But this Databricks is like it provides a different kind of extra functionalities on top of vanilla Spark, and it is much more optimized than original Spark. So because these guys know how the Spark is running, how to optimize the Spark, because they are the one who created Apache Spark in first place. So yeah, that's why Databricks is having a lot of demand nowadays. So at the core of a Databricks, we do have Apache Spark. So, and on top of this Spark, what Databricks providing other functionalities is like it provides cluster management. So, what clusters we need to have, and so how to different types of clusters are there, like interactive clusters are there, and these clusters, we do have virtual to create the clusters. We do have virtual machines on cloud. So these virtual machines are different types, like for all purpose virtual machines are there, compute virtual machines are there, storage virtual machines are there, graphic user virtual machines are there. Different types of virtual machines combinedly make is a cluster. So and these clusters will be managed by the Databricks. So in the Databricks console, we can able to see this cluster management, and we can create cluster, we can reduce clusters, we can create pool of a clusters, we can scalable clusters can be created in Databricks platform. And it provides Jupyter type of notebooks on this Spark architecture. Always in local vanilla Spark, we need to write that in command prompt, or else we need to install the Jupyter notebook separately, and we have to connect to the Spark. Then we have to run our code in the Jupyter notebooks. But that not case in the Databricks, because it inbuilt provides notebooks uh, for running the our code in on top of a Spark. It provides a notebooks type user experience. So it have admin portal where we can like give permissions, we can restrict permission for particular users on the workspace. So that is all provided. As I told, this is optimized for Spark. Like this Databricks engine is optimized for Spark, and it is 5 times faster than vanilla Spark. And on top of that, it provides databases in the sense it provides the catalogs, and it provides the tables, Hive Metastore. So these components it will be provided on top of Spark, but these components are not present in vanilla Spark. So yeah, it supports a data lake, and it supports ML flow as well. So yeah, we automatically if we take the virtual machines are like machine learning virtual machines, if we take that for machine learning models, automatically all the libraries are pre-installed in that virtual machines, like pre-installed in that clusters. So we don't need to try to install that separately. So all these combined functionalities at the core of Databricks is a Spark. Like with all the functionalities, this entire structure is called Databricks. This entire structure, we can able to this platform. It is we can consider this one as a platform as service tool. So this tool we can configure in AWS or Google or in Azure. But what it Azure Databricks have more functionality rather than other cloud platforms is that because this Azure is directly it is directly provided by the Microsoft Azure in Azure platform. But other clouds they are not providing directly. Databricks itself hosts their tools in the cloud, but here Microsoft directly provides Databricks here, and for billing and everything we can get a unified bill for all the resources present in the resource manager. We will get a single bill for this Azure Databricks combinedly we will get. So and it supports Azure AD integration. So for connecting to the Azure Databricks, definitely Azure AD is helpful because so in very large companies they do use Azure Active Directory, which is a governing tool. Like we can able to create groups of the developers into single group, and we can directly give permission to that single group. So it supports Azure Databricks supports Azure AD integration. So with the help of Azure AD, we can have single sign-on. So all these features are included in Azure Databricks, and so it directly connects to the all the storages which are present in Azure. As you said, like definitely we need to have storage like ADLS for to create a data warehouse on Azure Databricks. So it will be a lightning fast connection will be present, like with all the tools like all the Azure data tools like Azure Blob, ADLS, SQL DB, Synapse Analytics. It can able to connect very on high scale. It will able to connect like IO will be very high in this case. And there is a wonderful tool in Azure It is Azure Data Factory. So it is an orchestration tool. Definitely, most of you might have known this Azure Data Factory. Definitely. Then, yeah, this tool directly it will integrate with the Azure Databricks and it can run the notebooks at scale. Like we can have, like we can have more compute power. We can create high cluster, high job cluster pool for us to work the notebook in Azure Data Factory. It is directly integrates with the Azure Databricks, and we can run n number of notebooks parallelly in Azure Data Factory. So definitely Power BI integration also present. Power BI used for analysis of business. Like if you want to create data reports, actually, if you want to create reports. So with the help, with the introduction of Unity Catalog, so this Power BI can able to directly connect to the Unity Catalog tables in the Databricks. That is an added advantage when coming to the Azure Databricks. So it will connect to the IoT hubs, event hubs, and it will directly connect to them, and it will load the streaming data into the Databricks. So yeah, Azure ML is also one of the machine learning, like it is Azure machine learning models will be present. It will able to Databricks can able to connect to Azure machine learning models as well. So Azure DevOps, yeah, for continuous integration and continuous deployment, that is like very crucial nowadays in each business or each project. So definitely Azure DevOps is basically a very good repository tool, or like it can have multiple things in Azure DevOps. So it will directly integrate with Azure DevOps, and we can collaborate with the fellow developers, and we can do like we can multiple users can connect to single notebook and develop their own features, or like, and it will directly connect to, we can able to directly deploy to different environments. So all these added benefits is present. The total this package is called Azure Databricks, like a Spark, all the functionalities provided by the Databricks, and all the on top of that, all the functionalities provided by the Azure. So this total combined application, we can call that as Azure Databricks. So it is what can we say? It is lightning fast tool, and we can do multiple huge amount of data. We can able to transform that. We can change the business with the help of Azure Databricks. Do anyone have any doubts in this? I think it's understandable. Let me go through. So, what is the architecture of Databricks? First, for Databricks, it have two planes actually. One is control plane, one is a data plane. Control plane is data. It is controlled by the Databricks, and data plane is controlled by the Azure subscription. So whenever we create Azure Databricks, both this control plane is created and data plane will be created. So what will be present in control plane is like cluster manager, as we discussed, right? In Spark architecture, there will be cluster manager. So Databricks cluster manager will be present in that in control plane, and Databricks like user interface, like notebooks, these all the components like admin permissions, admin portal, and for data governance, like and there is machine learning user interface, and data engineer user interface, and data catalog user interface. All these user interface will be present in a single workspace. So and yeah, in that workspace, all these user interface tools are present. So it contains cluster configuration. So which types of the clusters we are using, all that, the for each cluster, how many worker nodes we can assign, how many like for each cluster we have one driver node, and we can include multiple worker nodes, like single to many, we can always configure that. So all these configurations can be do in the Databricks web page. So that will be present in control plane, and we do have distributed file system, so DBFS. So this will also be present in Databricks only. So at least we can able to see in Databricks. so in control plane, in data plane, so whenever we configure Azure Databricks, so different components will be installed in the Azure subscription resources. Like what it will try to create a virtual network and virtual network security group in Azure subscription. It will create Databricks workspace. Databricks workspace is like it's a web. It will be having all the monitoring sessions and all the things will be present. So it will create that one. It will create a main blob storage for a Databricks. So these blob storage, why it is used? It is like metadata, meta store for a Databricks. So these DBFS connects to the blob storage. In DBS, we don't have any storage. So this blob storage acts as a data distributed file system for the Databricks. So that's how it is connected. So like this, it will be these two control plane and data plane combinedly provides the Databricks architecture. So if any user wants to create one cluster in like we do have one cluster, if he want to create high performant cluster with more CPU, so what he can do, he will go to the cluster manager and he will try to create configure cluster. So this cluster manager connects to the Azure resource manager in Azure. So it will connect to the Azure templates or inbuilt, like this one will be happening internally. This connects to the Azure internal resource manager and it will try to create virtual machines for the cluster. So cluster is nothing but group of a virtual machines. So these virtual machines will be present in the Azure. So in the same virtual network of that where Databricks is created, right? In the same network, it will able to create this cluster. So like this whole package is like these two planes will act as a Azure Databricks. And if any user want to connect to the Databricks, so as I told earlier, Azure AD is like with the help of Azure AD, directly he can if he have Azure subscription, he can directly able to connect to the uh, uh, Azure Databricks, provided he have access. So like this Azure AD group of a people by authentication on the Azure AD, he can able to connect to the Databricks. It acts as a single sign-on. So all these features and facilities are given by the Databricks in Azure. This is how Databricks architecture on high level. So there are a lot of components will be present internally. So yeah. Yeah, we do have some utilities given by the Databricks, like on the top of all the functionalities, as we have discussed earlier. So it also provides some more utilities for development, like to make the development experience easy, like to enhance, it will enhance our development experience. So these utilities are nothing but some Linux based commands. So and these are like file system utilities. So these are I think most of you might know. These are the Linux based commands for like connecting to the blob storage and listing all the files and removing files or creating files. So all these functionalities, it's very lightning fast. If you try to remove any particular file, it will be very quick. If you want to create any file, it will be very quick. So all these functionalities will be provided by the Databricks and notebook workflow utilities. So there, in some cases, we do have some scenarios. After running one process, we need to run other process. Like we can think as a dependent process. So at this point of time, so we can have notebook workflow utilities. Like we can run for particular after completing particular notebook, then we can run this particular notebook. Like that, we can have notebook workflow utilities. So we do have widget utilities like so if we want to take output of a notebook into the another notebook, so there is some scenario based things like differently. We need to have output of a one notebook to another notebook like that. Then definitely we can use these widget utilities and take output of one process into the another process. There are secret utilities. These are useful. These are very useful for in Azure Databricks. Like if you have any server, So for the password of the server is like we need to hide the password of the server. Then where we can hide? So these data bricks it will connect to the Azure Key Vault. So Azure Key Vault is nothing but like it's similar kind of key vault. Like so all the keys, the passwords we can save in the Azure Key Vault. So these data bricks connect to the Azure Key Vault with the help of the connection, with the help of scope credentials. So then it can able to connect and it can fetch the secrets from there. So if we try to integrate our passwords in the code, means definitely there will be some misuse happening on the passwords. So this functionality is very useful, so that the secret will be present in Azure Key Vault. We will fetch the secret at whatever whenever we require to connect to the particular server or particular data lake. There are library utilities are there. These library utilities are like third party things, any other third party packages we need to install, like say pandas or numpy. If you want to install those libraries, definitely we can able to install. And if you want to install scikit-learn, or if you want to install pytorch or any other machine learning tools, or definitely we can always install in the Databricks. So with the help of all these utilities, definitely Databricks provide a better development experience compared to other tools in the industry. So yeah. So any doubts as of now?
Yeah, one thing, then so
Yeah.
actually, do we normally use Databricks ML side, or do we use really ML ops on Azure side in real world?
In real world, yeah, it's a very good question. So Databricks, it's used for both data engineers and data scientists we can use. But ML like data scientist, like creates whoever use the algorithm and create output, right? Like at least they will use the algorithm in some particular code and it will give the result only. That's it. Like creating machine learning, creating the algorithm on top of machine learning models. Only the development part we can able to use in Databricks. Like it contains, like we can install multiple libraries and we can develop. So we do have data, right? So this data, we can use the data and we create the algorithm on top of a model, like say regression model we can create, or classification model. So any model we can take and we can create an algorithm, and these algorithm will be given to the machine learning engineers. They will maintain the algorithm. Like data scientists will be working on creating the models and algorithms, but the maintenance of that will be taken care by the ML ops actually. You understand, right? Like any
Yeah,
other?
yeah.
Only for development purpose we can use Databricks utilities. Sorry, Databricks for working on the code part and other thing. Yeah. So coming to the yeah. So this is a practical example what I am doing now. Like first we will try to there is one file, sales file 2019. It's a long back data. It's a CSV file. We'll try to upload the file and we'll try to read some data in the file, and we will change the data. We'll do some transformations of the file of the data, and then we'll analyze the data and we can go with the questions. So yeah, let me, is my screen visible?
Yeah. Yes.
Okay. So this is a Microsoft Fabric. For demo purpose, I'm using this since I have a subscription on this. So this is also a latest tool, right? So I already uploaded file. Yeah, sales 2019 is the file I already uploaded. So I will try to read the data in the file. So I have file path and folder. Everything is already set up. So these are the basic functions we will be installing. Like we will already these are present in the Databricks. Just we are importing in this particular notebook. This is the notebook style. where like we have multiple cells are present. If you are not familiar, so whenever we write this cell and we try to result that, result will be appear below this cell. Like that, I have created these many cells, like for to read the data, to analyze the data, and to change the names, like column names, or doing some small transformations of the columns, and like analyzing
Are they
and creating
Python
some
libraries?
aggregation. Yeah, these are not Python libraries. These are functions which are inbuilt PySpark functions. So Spark is like engine, right? It do have some functions inside. So it supports, the Spark supports multiple languages as well. Like it supports Python, Python as we call it as PySpark. It supports SQL. It supports Scala. It supports R language. So we can write our code in multiple languages, but Sparks always understand the language which we have written, or like at least we need to first inform the Spark which language we are writing. Like if you see here, there are different languages are there, like the Spark SQL is there, as I told, Spark, Scala is there, R language is there, Python is there. Like first, at least we need to inform the Spark in which language we are writing. So Spark will understand, and then it will try to give the result. It's not like a Java or C sharp. It's the same language we need to write to that .NET framework or that. But Spark is a framework. It will automatically understand multiple languages at a single time. Like at least we need to provide the information which language we are writing. So yeah, these are the Spark. These are Python libraries only, Python functions. But here we can mention it as a PySpark because it's a Spark based Python, right? Yeah, these are the SQL functions. So we are just importing, and SQL types, data types, all are SQL data types we are using here. So and we are importing all these data types and functions in this notebook. So if we try to run this single time, so all these functions will be imported in the notebook, and we don't need to re-import the other functions. This star is always a costly operation, but this is like star means it will import all the functions. Means whatever the modules which are present in a single function, it will be sorry, all the functions which are present in a single module or library will be imported in the notebook. It will definitely increase the size of a notebook. And so if you are doing high memory, very large data set, we need to definitely take care of this, and we need to import required functions only. Yeah, I'm importing SQL functions. Since it's a demo, I am importing all the functions, and data types also I am importing. So I have created a file path. So this is a file path, like ABFFS is a, file naming convention which we use in Hadoop. So at least in big data. So this is ABFFS, and this is a demo container, and this is a, fabric lake house. So this is the like path how we can create. So this is a workspace where like sorry, this is a workspace, and this is the fabric URL, and this is data lakehouse. This is the lakehouse uh, dot lakehouse, and this is the files is the folder where our in files, in folder name sample data folder, we do have this CSV, right? So like that I have taken. So let me read the data. Since it is a CSV, I'm reading in the format of CSV. So I can give the file path and folder name here. So this is entire path we need to provide here. So after creating data frame, we can display the data frame. What content is present in this data frame, we will try to able to see this at least. So this is how we write the PySpark code. So spark.read.option. So since it have header, and we are using that header as a true, and Infer schema is nothing but it's a function where it will try to analyze the schema present in the data set, like at least in CSV, and it will create the schema for ourselves. So, but this is not like very feasible for large data sets. So always try to avoid this and create our own schema. That is better actually. Yeah, for this demo, I'm just going with the info schema, and we need to provide a path, full path. So we'll try to read the data set, what is present in the data set. So this one have the cluster and everything will be in background. So the cluster is nothing but one, at least one driver node, at least one worker node and one driver node. So yeah, that is a cluster. So like multiple group of worker nodes and a single driver node make it as a cluster. So at least we need to have one worker node. So then we can create a cluster. So if we try to able to read the data in the CSV file, there is this is the sales data, I think. So if you see here, order ID is a column, product is a column, quantity ordered is a column, and price, order, and address is a column. So this one is a data frame. We call this as a data frame. If you see here, there are like multiple jobs have been triggered, and it is triggered, and this is nothing but we have discussed Spark architecture, right? First the code is submitted to the driver node, and the driver node connects to the cluster manager, and it will connects to the worker nodes. All this process will be captured in these jobs actually. Let me open one of this. Okay, so this is the internals of the Databricks. Like, so at least the same scenario in Databricks also, it will be the same. Internals of the Spark will be like a driver node, worker nodes, cluster manager. All these informations will be present here. So as I told, like there will be direct acyclic graphs as also. So that is also we can able to view here. So for time being, I'm just going ahead. Like, yeah, I think it's open. Yeah. So this is the total direct acyclic graph. This DAG means nothing but direct acyclic graph. Direct acyclic graph visualization. So what happens here is like it will try to scan the text, and it will be if anyone from the Hadoop, they understand these RDD structures and map reduce already present in the Hadoop, right? On the top of Hadoop only this Spark is created. So like that, like it will try to check the CSV, it will try to do like a number of partitions, and it will conclude, and it will send the data to the uh, send the data to this application. So this is the data what we extracted. So like this is the data, I understand. So how much data is present, how much rows are present in this particular data, then we can go always count. Df dot count means it will just provide how many number of rows present in the data frame. It is counting number of rows. So there are if you see here, there are 12,000 rows in this particular CSV file. So that many rows, it fetched those many rows, it read those many rows in 13 seconds. So in some cases, it is less than 13 seconds also. It is very fast, what I mean to say here. And we will try to see the schema of this data frame. So it always gives this, so at least in Fabric, it will try to give the uh, function which we are trying to run. So we'll try to, yeah, this is the schema of that data frame. If you observe, if we want to provide the information infer schema, all the columns will be strings only. I will show that. If you provide info schema, let me create one more data frame, and I will show you what is the use of info schema. So here in data to frame, we are not using this function info schema, and then we will try to display the schema of the second data frame as well. and we will be able to see the observe the difference. If you see that second data frame info schema, if you won't provide info schema, this one is became is an integer. Order ID is always an integer, but it assumes as a string because we haven't provided the option info schema. So this info schema will try to analyze the text in that column and it will provide the schema for that. Like if you see here, price is double. Here price is string. So like that, it always like at runtime, it will analyze that and it will provide a schema for us. Okay, let me remove this one. So yeah, if you see here, this is info schema for this one. And for order, this is, I think this order is, let me run this display data. So this order is, it's a date format. But if you see that we are able to only get, it is a string. So it is like some cases we need to cross check even though infer schema is it provide the function, it won't try to analyze the what type of data is present. For in such cases, we need to change the data type of that particular column, and at least there is some gaps in the column names. These gaps we need to remove for like for a good coding or for good columns or data frames table creation. Definitely we need to avoid spaces in between the column names. So that's what I am trying to do here. Like I will try to remove the column names. So for I have code in handy. For time being, I'm just copying the code. So yeah, this is a functionality where like we are just renaming the column. What this functionality also will be directly when we are typing, it will throw this function name for the development purpose, like to make the development quick. So we are removing the spaces in between the column names. Like either we can go with like either we can go with like underscore underscore or like camel case or underscore case. Like we can write order id as like order underscore id, or like order id. Camel case is nothing but like the whenever the word is changed, we'll always try to capitalize the word. That is, this is a camel case. So we can prefer anyway. It's up to the developer. He can change, he can do whatever he required. So I'm running this and see the order column is also like it is not properly given the column name. We will try to rename the column name as order date. So this is the order date. So all the column names have been done as expected. Now what we need to do is like so the schema of the column is not yet changed. If we try to read the schema of this second one also, we'll try to we will get only uh, string for the order date only, not date column. So yeah, order date is still string. We need to change. We need to change the data type of that particular column. Okay, let me create one more data frame. So these are all the functions with command, with column name renamed, with columns, with metadata, with watermark. So yeah, with column is the one we are using as of now. Column. Which column? With column means it will try to add a extra column. What column we can, what which data type we need to change? The same column we can take. Like order date is the column. We can take the same column name here, and we'll try to change. We will cast this order date into the date functionality. We need to do cast actually. We are trying to cast the order date to as a date. Okay, I think we do have a scenario. We'll try to print the schema of this. So yeah, if you see here, order date is the date, like the schema of the date is changed now. It is like a date schema now. So like that, we can able to change the data types of the schema. So we can do multiple transformations. We can do joins. We can do n number of things in this PySpark. It's a very lightning fast actually. So we'll try to do some aggregation. Like, so if you see the data frame, let me display the data frame. So if you display the data frame, I think here order date is camel. Let me see. Okay, it's unable to read the data. Okay, let me go through this. Which product gave most money? If you see the products, so there are different types of the products. So like iPhones are there, MacBooks are there, and like prices of the each product is present here. So we need to try to fetch which product gave good amount of sales. Like in case of the amount, at least we'll try to able to fetch that one. So for that, I will take df4 equal to f3. So we are trying to group by here. Group by product we are doing. Group by df3 dot product. Okay, and dot we are doing. We are doing sum of the price, like all the products, including total amount we got from that particular product. So we are doing sum actually for the sum of uh, sum of df dot. Either we can write the column names multiple ways, like this also we can able to write like single quotes we can give, and we can write as a price like that. Like we can write column names of df3 dot product as well, or like some dot price as well we can able to write. And then we can, at least we will try to change the name of this. We can do like this also, alias. Can able to change the particular column name here like that. Total amount received by the product. Total amount received. Total amount received by the product. We can make it as this one, and we will be try to order. So we will make, we want like which amount we got high, that one, like at least we need to do order by here, order by descending of this particular column, total amount received. So if we try to do this, we will able to achieve which product gave huge amount of money in terms of money perspective, at least. Display, we can able to print data frame as well, or display data frame. Like we can directly, let me print data frame now. dot show. You do like this, it will try to as a text format it will print, not as a table format which we saw earlier. It try to execute. See, at least MacBook Pro is a laptop. MacBook Pro laptop gave total a huge amount of money here. Then iPhone, then ThinkPad laptop. So these are the products which gave huge amount of money. So on decreasing order. So like that, we can do n number of analysis on a particular data. So and we can perform like this is just 12,000 rows of a data, but we can have like million rows of a data. The same compute power will be it will give best performance compared to other tools. These Databricks give. So yeah, this is like practical we have done. So this for demo purpose, I have taken one small CSV file, but in course we will try to able to solve a particular project, like how the project is built. So and what is the architecture? Mainly in projects we follow medallion architecture. There will be raw layer, there will be like a raw layer, stage layer, and presentation layer. Like we can call them as bronze, silver, gold layer as well. So the bronze layer, you can see this one up till here, we can reading the data and changing the small column names, like just reading the data and changing the raw layer will be the is same format, whatever the CSV, right? The CSV will not be generated here, right? So at least CSV will be generated in different location or by upstream systems like whichever generate the CSV file. We need to extract the CSV file and we need to keep it in the data lake. That is a raw layer. So after that, these small transformations, what we have done, right? Like changing the column names, changing the data types. So all these things will come under stage layer, like a silver layer. So we'll change small transformations and data types and all these things, and we can refine the data. So if any null values are there, any duplicate values are there, we'll try to remove these duplicate values and try to remove these duplicate nulls. So and we will refine the data and we will save that into Parquet file format. So once it is in Parquet file format in silver layer, then we can go ahead with the aggregations, connecting to the different sources and connecting, aggregating the data and sending to the gold layer. In the gold layer, we can maintain as a files or we can maintain as a tables or like normal Spark tables we can able to maintain, or like we can able to maintain Delta tables. So based upon the scenario of the project, we can maintain different types of tables there. So after that, the data will be sent to from gold layer. The downstream systems will able to fetch the data, the refined data, and they will use for the reporting purpose. So this is total entire architecture how we will be working on Databricks. Okay. So do anyone have doubts? We do have Q&A, I think. Yeah.
So whatever the filters that you had done now, so these questions
Yeah.
will be come from the developers that they will ask that they want some group by order or group by price name. So how we do it?
Yeah, so the definitely like there will be providing a for developers the manager team, or they will be providing certain story, user story. Like we need to extract data, we need to refine the data, and we need to send to the downstream systems. So they won't be asking like these at least these column these naming convention, all this one we need to take care of that. So naming convention, we need to check whether nulls is acceptable or not in the eligible criteria, like so all this one we need to ask the either we are supporting data scientist team or like Power BI team. Based upon the team, so we need to ask them questions like whether nulls are acceptable or nulls we need to remove it, or like based upon the scenario, like we need to group by the scenario. If you see here, they will ask as a like this question. That's it. Like which product gave most money. That's it. So we need to analyze ourselves. So how we need to able to get the result. So that is the logical. They will be just give the
Yeah, say
questions.
yeah, say
Yeah,
for example what you had done now, like which product give most money. But say for
yeah,
example, is a huge data in the table, but we don't know what are the columns and the data table present in this. So how can we
yeah.
sort it down? Because we cannot open in the Excel, right? The simply it's not a simple file to open in the SQL or something.
Yeah, that like this we have to run. See, if the file is present in data lake, we need to create a data frame like this. So this is the data frame, right? This is just a data frame. We need to create a data frame. We need to go through the column names like this is the column names. This will give the column names, right? So what columns are present, and we need to analyze at least some amount of data first in the first place. So we need to do the data types of the data. Until unless we do data types, like if any unsupported data types, we don't able to get the result. So we need to change the data types according to the scenario, and we need to fetch the result like this. So
So whatever
these are
the
not Excel files,
groundwork
right?
that we
These
have
are,
to do on the
yeah,
raw table, what groundwork required,
yeah,
depending
these are
upon
all
the
the
PR
groundwork
they
we
had
need to do.
provided. Okay, sure, yeah.
Yeah, this is all the groundwork, like analysis of the data. At least we need to do. They will just provide the files, or like they will just provide a SQL table. We need to connect to the table. We need to extract the data. We need to do like we need to extract data and keep it in raw layer. From there, we need to take the data into the data frames. We need to analyze, transform the data, and then we need to create a like Parquet files. We need to create the Parquet files are a file format which is it's its default default format is for Databricks. Like whenever we want to, the Parquet files are mostly customized or optimized for Databricks. So if we try to read the data from Parquet files, it's very huge amount of data. Multiple files we can able to read at a single time. So that is the Spark architecture. It will connect, each worker node will connect to the single file in the see if we have similar files like 20 files in a particular folder. So if we try to run data frame, read that folder, at least not the particular single file, will read the folder means. So these Spark architecture, all the worker nodes will connect to each file. Each worker node will connect to each file. Each worker node will read the data from each file, and we will get a consolidated result. Like it will try to read all the files, whatever the rows in all the files. Spark will read that too in very lightning fast way, and it gives the count. Whenever we try, in the first scenario I used only one file, right? So if we have sales, if the at least schema should be the same, like this is one file, right? If we have another file like 2020, like sales 2020 file will be there in the same particular scenario, like 2020 CSV file will be there, providing the schema of the files will be the same. So if we have like this in these two files, right, we will try to able to read up till folder name only, not the file names. So if you try to read up till folder name, it Spark will assume these two files are similar files, and it will collaboratively it thinks as a single data set, and it will try to read from two different files at a single time. And when we try to count that data files, count the rows in the data files, right? Consolidated count will be coming both in file one and file two. So means it read all the rows in file one, and it read all the rows in file two, and it gives the result for us. So we can perform this type of scenarios in Spark. So this groundwork, everything we need to do. That's what we work like for extraction data, for transforming data, and loading the data. We are responsible engineers. Any other questions?
Yeah. Actually, Azure provides different services, right? Like Azure Databricks, ADF, Synapse Analytics. How do you
Yeah,
know when to use or
yeah.
when to
When
choose
to use
different
what?
tool?
Yeah. So basically, so when we are at the early stages, so there will be architects will be present. Actually, they will decide which tool we need to analyze. But we can also able to try to analyze how the architecture is there, how our project architecture is, and then we will try to analyze, and based upon the agreements, or like based upon the provided information by the architects, we will try to use the tool. But Databricks is always useful for for when we are working with a huge data, like 2 TB of data, or like any data, huge amount of data, like 10 TB, 20 TB of data in a particular project. Definitely for transforming, at least we will try to use Databricks. So Databricks also supports the multiple languages, right? Like if you want to write in SQL, we can able to write. If you want to write in Python, we can able to write. So Databricks is more code friendly tool. When coming to the data factory, it also can able to extract the data, some minimal transformations it can do. But if we there is a data flows concept in data factory, if we go through the data flows concept, whatever we are doing in a coding language here, that we can able to do without coding. Just like it's a minimal coding is required for data factory. But Databricks is main core component for Azure Data Engineer, at least the Spark language and everything. The next future will be totally the Spark language, PySpark language. What can I say? So that's why I have given demo on Databricks rather than Data Factory. Data Factory is also very capable tool. It can also achieve whatever you want to achieve in Databricks. We can also achieve in Data Factory, provided if the data is less.
Okay, what about Azure Synapse Analytics? So Synapse Analytics runs on the Spark spools, right?
Yes, Synapse Analytics we can able to do. Synapse Analytics is if you use Synapse Analytics, then we don't need to use the data factory and Databricks. So Synapse Analytics itself, there only we can able to perform all things, uh, whatever the Spark pools we can create, and all the Spark coding. This is similarly kind of Synapse Analytics. This is what Synapse Analytics looks like. So you are seeing the screen, right? I think screen is visible, right, for everyone.
Yes.
Is screen visible?
Yes.
Yeah. So this is how Synapse Analytics look like. So I have Synapse Analytics subscription, so that's why I have worked the Spark code in Synapse Analytics. But Databricks interface is different, a bit different than this. But yeah, Synapse Analytics also we can able to use. If we have Synapse Analytics, then we don't need to require Data Factory and Databricks. Synapse Analytics is much more expensive than Databricks and Data Factory. There will be always restrictions will be there, like cost restrictions, at least price restrictions will be there. So due to that, definitely all the like all big players can use Synapse Analytics. But yeah, it's more expensive compared to other.
Okay. And in terms of course curriculum, how much time we're going to spend on a theory and how much time we spend on practicals?
So theory is always important, because if we understand the fundamentals and the basics, definitely you can able to at least you can able to crack the interviews, or you can able to pursue the certification. So the theory is very much important. So practicals also important similarly. But theory is like I can do 40% and practicals is 60%, 60%. What I'm thinking, theory is also very important uh, to at least to work in to complete the certification. Theory is very important actually, and practicals are important for job related things. Yeah. 40-60% what I can see now.
Okay. And are you going to provide certain questions that we need to work at home, like after the class, or just
Yeah,
we need?
I can able to provide. Yeah. no problem. So we do have a good amount of uh, like uh, at least demos and at least from test samples we have, so we can able to provide the questions and some scenarios we need to explore to do on our way.
So if you want to put the topics in ascending order, like SQL, Python, or whatever the database you said, so
Yeah.
what will be the order then?
So in this course or like in the I didn't got question.
No, in the data,
Eh,
no, in this course only, data engineering. If you want to put
Okay, in
the
the data
topics in
engineering,
ascending order.
this is the way. We'll start with data factory, which is very easily we can able to capture this data factory because it's a low code experience. So, like in some projects, they only use data factory and they use SQL for transforming the data. So at that particular point of thing, so first this is a order what I'm thinking. Data factory and first Azure. What is Azure? At least we need to go through some basics of Azure, data factory, then Databricks. It's a high extensive coding thing, but Synapse Analytics is it's a very huge topic. What I can say, at least we will try to cover most of topics in Synapse Analytics because it's a data warehouse. So we do have a lot of things in data warehouse, lot of concepts like schemas, modeling. So a lot of things are present in Synapse Analytics. At least for a particular use case for data engineers, what are the contents we will be covering that. Then we will try to like the storage and stream analytics. The storage already we can cover here in data factory. So and the stream analytics we will try to able to cover. And so most of data engineers won't use Azure Stream Analytics. Rather than I will try to for this stream analytics I will try to include the fabric. At least for stream analytics, at least I'll try to include fabric. This is a fabric. This is a new tool which is recently recently came to general availability in last December. So here we do have real time analytics. Yeah, at least we can cover this real time analytics. So it's basic understanding of fabric. It will be helpful for all the data engineers. That one we can able to cover here. And other Azure data stacks like I told you, like Fabric, Lakehouse. So all the components we can able to cover here. So main components are these things. And coming to storages and AD, like giving permissions, that one we can able to cover. Uh, Parallelly with Azure Data Factory, Databricks, and Synapse Analytics, everywhere we will be dealing with Azure Storage. So if you have any questions or any doubts, so we can go through in this session of Azure Storage explicitly. And real-time stream analytics, we can able to go here. Any other questions? Yeah, this will be the mostly the components what we gonna discuss in this course. And I will provide some like interviewing questions and so like what questions and some scenario based questions we'll try to cover. At least that will be interesting. Preferably like what in my previous experience I have faced and what all our the data engineers are facing, different type of scenario based questions that we can try to able to cover. After completing the topics, we'll try to first start the next before going to the next topic. We'll try to do the scenario based questions will be asked for the at least for a group of topics, like not for each topic we can able to go. At least like if we complete like 10 topics, then what are the scenario based questions we'll be asking on that particular topics, like that we can deal with that as well. So any other questions or suggestions?
Teacher, in
Yeah,
Azure,
I
you will
Yeah. Yes, please. Hello.
Sir, how long the duration of this course?
So the duration will be like more like at least 40 to 50 hours in between. So it is it's not a small topic. Each topic takes like at least 10 hours or so. We'll try to fast forward the some topics, and so whatever the theory part, right, like where we are getting uh, more number of scenario based questions, that one definitely we will take more time compared to other topics. Yeah. Any other?
When are you planning to start the course? Timing? When can you share the details?
Yeah, I can share within 1 week, probably in the next week. So or the week after, we'll try to start the course. I will be sharing all the content, like, so this is high level contents what I provided here. So whatever the components we are dealing, and so I'll be providing a PDF for that as well. I think we do have a PDF of Visualpath, so we can follow the same thing, but added or like removing some topics or adding some topics we can do on a go.
So we have only online course this one, or will get some offline courses or some system work? What is
Only
the best?
as of now, this is only online course as of now. So I haven't got any approach for offline course as of now. Let's see how it goes.
So in this course, what are the prerequisite skills are required?
Yeah, the main prerequisite skill is like first patience actually. So we need to have a lot of patience to complete this course. Uh, that is one thing, and some SQL skills are required. So if anyone is familiar with the SQL, definitely they will get a lot of interest to work on this course and to complete this course as quickly as possible. Like, so definitely SQL skills are required, and some programming skills or logical skills. How the approach, the which way we will try to approach, that is main important, not like language or not like any coding skills we require. Nowadays coding and everything we are getting in online only. Most of the things we are if we forgot or if we try to want to get, definitely we will able to get the code. But the logical approach, how we can able to achieve the solution, that what we require. So that logical approach, definitely we can able to learn. If we don't have that logical approach, we can try to analyze that, and we can build that logical approach. So that is not a rocket science anyway. Definitely we can learn what we can say. These three skills are required, like patience, SQL skills, and logical approach.
Sir, I'm working as a BA developer as of now. Working as a Java developer. So can you put in the resume after completing this course as a Azure developer for the past 1 year?
Hello. Sorry, your voice is not clearly audible. Can you repeat that? I think some echo is
Currently,
coming. Lot of echo. Yeah, please. Can you text that at least? Like I will see. Or like
yeah, sure. Yeah.
So here, three certifications is mandatory for this training.
the certifications is not mandatory. It's a added advantage. So I started my journey way back in 2017 or 2016, but I have done certification in 2020. So yeah, 2021 I have done certification. If you see, that is not a mandatory, but it's a added advantage, at least we can tell. Hello, we do have some questions in the chat. Sorry, I missed it. Okay. Master slave architecture, I think Shruti. So master slave architecture is like a setup, like the driver, that one we can call it as a driver node and worker node. Whenever a work come to the driver node, it will try to split, or it will try to split the work into a distributed way, like few chunks of work it will be splitted, and it will be submitting to the driver node. So what driver node will have? Driver node will have CPU, GPU, and some RAM processing and other things. It will directly connect to the data where the data is present, or like the data will be present mostly in the memory. So it will connect to the that memory, and it will perform the whatever the task given. If you say just now I said like a count, right? Or like so it will driver node will send how many rows present in the data. It will ask the worker node to count that. So one worker node will be assigning the task, and it will be counting the data. At least in that, in the worker node, the data will be present in the RAM of a worker nodes. It will try to count how many rows in that particular worker node, and it will send back the count number to that driver node. And similarly, all the worker nodes will count their respective rows in the worker node, and it's sent back to the driver node. The driver node will be displaying the number of counts present, number of rows present in the data frame. Whenever we create a data frame, so the data will be captured in the worker nodes RAM. It can be like it will be partitioned into it will be creating into multiple distributions. That's very high level, it's very in-depth knowledge, uh, that is very, at least very interesting. It will be very interesting for to understanding this architecture and everything. What's airflow and what's the use case? So uh, airflow is Apache Airflow, which is used for orchestration purpose. So similarly, kind of Azure Data Factory, it can create dependencies of the task, and it can create multiple jobs, or like multiple small jobs in the in the particular job. It will create multiple small tasks in the Apache Airflow job. That is not covered in this course as I can see. It's totally uh, Azure Data Engineer course, specialized for Azure purpose only. So instead of Airflow, I think in this course you can learn about Data Factory, which is a better orchestration tool compared to Airflow. And
So
is Azure
here
Key Vault?
Python,
Yeah,
Scala, Spark also is required, right?
yeah, mostly PySpark. So we'll be dealing entire course with the PySpark only. Some basic understanding of Python is required. Scala is not required because uh, this is Python course, like PySpark course. We can write the same, whatever the same syntax I have written here, right? In Scala also we can able to write the all this code in the Scala. So if we try to that is our choice, because I work mostly in PySpark, and a lot of projects are working in PySpark as of now. So I think PySpark is a better approach when compared to the Scala. And Scala, we do have some projects working on Scala as well, but Scala and PySpark are similar kind. There is small variation will be present coming to that.
So here little bit is coding or scripting more here. For,
Yeah, coding is definitely required, but not that much extensively, which we like Python coders or like any other code engineers will be doing. Not that much extensive, but yeah, it is similar kind of SQL coding. If you have any experience on SQL, so it's similar kind of SQL only. Just we will be doing with transforming the data mostly and other things. Yeah, Python skills are required. Definitely, those are useful, but yeah, here we don't use that much. I will have one session on Python, so where we can go through the Python, at least some basic things. So like creating some user defined functions and other things. Srini, I think, Srini, I'm working as a BI developer for past 7 years. Once I complete this course, I can put experience at least 1 2 years relevant experience in Azure Data Engineering. Yes, definitely you can able to keep like 2 years or 3 years as a data engineer. And if you complete this course, definitely you can able to, and I will provide the interview questions as well. So yeah, definitely you can able to achieve the whatever your goals are. Yeah, how we can set up the environment for this course is like, definitely we need to have Azure subscription, uh, and in Azure subscription, so there at least we need to have one subscription like free account will be provided in Azure. uh, so if you try to use that free account for a monthly basis, at least it will last for 1 month usage. Then we can able to try to create our Databricks workspace in Azure environment, and we'll try to connect to the all the files. We'll be having all the different files. We will able to connect in the data lake, and we'll try to create mount points and all things we can able to create. So at least we need to have Azure subscription for that. Definitely we need Azure subscription. So any other questions, guys? I think
May I
it
know
went
how many years
quite.
required for this course?
How many?
How many years experience is required for this course if we get a job?
So actually, you can. So if you start as a data engineer now, you can keep at least 4 years of experience or something around. Like if you complete this course, you can keep like 3+ years experience. Like depends upon the understanding the theory parts in this course. You can keep like 3 years or 4 years. Definitely, you can keep that much of years experience. So, and then you can answer all the questions, or you can perform all the activities which assigned for this data engineer space. At least uh, you need to understand the theory part very much, actually, because nowadays a lot of interviews are happening mostly on theory part. So practicals, they are not, they are just evaluating whether you can write a code or not. That's it. So but theory, definitely they are very much keen. They will be asking a lot of questions on theory. So at least you need to understand the architectures. Main, that's why I have focused today this demo on architectures only. At least you will get some basic idea. The the like the architecture is very important, because like you will get like at least 20 to 30% of questions in architecture only, mostly. So if you able to achieve the architecture, complete understanding of the architecture, so you can always link up this architecture, and you can analyze how this process will be doing. And most of the questions will be performance tuning questions also. So if you cross 4+ years of experience, definitely they will be asking performance tuning questions. So yeah.
Are you providing any materials on this course?
Yeah, I'll be providing the sample data and this PPT which I have created. I'll just try to do some elaboration of some functionalities what I have discussed, and I'll create more slides for this, and I'll provide this PPT and the sample data, and whatever the notebooks will be developing in the course. That one I'll be able to. Then definitely we can able to extract this notebook, download as notebook, or like py file. So if we'll try to download, this notebook will be downloaded, and once it is downloaded, let me refresh this. It's downloaded. One
No,
minute.
theoretical part, any document, any material will be provided.
Yeah, theoretical part, this PPT, and some, mainly this PPT. I will try to include all the definitions and other things in this PPT only. You'll have all the definitions, and so what we'll be discussing for particular day, on particular day, what we are discussing, everything I'll include this in PPT, so that if you see this PPT, definitely you will try to remember the class what I have mentioned in that. So for theory purpose, you can always check this PPT, I think. And definitely if you want any other external information, I will provide here. from where I have taken the source for that for that uh, images or other things. So any other questions? So everything is fine, right? Like it's already 1.5 hours. Thank you for showing interest in this demo. Yeah, very much appreciate your patience and other thing. Yeah, thank you very much. So any other question, just ping me or like here in the chat at least something. I will try to able to answer. So, yeah. Thank you for the session. Thank you guys. Thank you. So we don't have much time, or else I would have at least try to introduce or something. Yeah. Thank you. Bye.